Yo. What's up, everybody? Welcome back. Today we are working on our window manager yet again. And today's topic is trying to run Wayland on Wayland. This is our window manager. Look at this bad boy. He's got like a little mouse. He's got a window rendered inside here at really low resolution. Ignore the fact that, our window manager will only display one window at a time. They have no window borders. They're not rendered at the right resolution or in the right spot, and they're not interactable with the mouse in any way. Ignore all of that for now. We'll pretend all of that worked. It is annoying to implement features with our current setup. Because our current setup is the window manager will initialize. So right now, like in the real world, your window manager is like in charge of displaying things here. Well, I shouldn't say your window manager. I should say a Wayland compositor is responsible for managing the monitor and like doing pretty low level raw GPU calls to like put stuff on the pixels of the display, right? So it's kind of like you have window manager sits here and he kind of talks to, dev DRI card 0 or something, right? He talks to this guy and he says things like put pixels on monitor, right? On monitor. Which is great. We can do that. Except we already have a window manager doing this, right? Kwin lives here, right? This is what's rendering like this window right now. And he's doing this, which means that if we want to test our window manager, even if we could fight Kwin for this resource, we wouldn't want to, right? It would look like shit. My monitor would be like flickering between the two. They'd be fighting, right? So in reality, what happens is we try to like talk to this guy and he's like, no, fuck no. Kwin's busy, bro. You're already doing this. User, don't do it twice. And that's like a little bit annoying because it means that we have no way of testing this thing without popping open like a virtual machine to do this again, right? You could also hit like Control-Alt-F blank on your keyboard and test over there. However, I don't have dual PC streaming, which means that if I were to do like what is being streamed right now is Kwin. So you guys wouldn't be able to see anything. And it's also inconvenient because Control-Alt-F blank to go to your other window manager is just like annoying. So what other window managers do is they will actually have a backend that allows them to run in another window manager, right? So what I really want to see is I want to see Kwin's here, right? Kwin. And I want to open my window manager inside a window in Kwin. And this is like my window manager here. And we can do all of the testing for all of the stuff that is above the like very, very base layer of the system, and we can do all of our development for that stuff in this scenario, and then just like flip into the virtual machine or Control-Alt-F whatever for testing once we've proven it works in this scenario. And so what we need to do is we need to like take all of the code that interacts with the system and say, I would like you to run in the context of a Wayland client, which is wonderful. We already have Wayland client. We have one in the same repo that we've written ourselves. So we should be able to just leverage that existing client and put it in our event loop and have it be one of the things that runs. So basically like take the existing, we have interfaces already for like GPU. We have one for like input. And I think there's one for something else. I can't remember right now. But basically we just need to say like GPU is implemented by like DRM, right? The like low level GPU stuff. And I think that we just want like another implementation of this for like Wayland. And same with input. Input is, we have one implementation of lib input, and then another one that will also be Wayland, right? So that's the plan for today, is to try to implement these like Wayland interfaces for these guys so that we can run our window manager in a window manager so we can do our testing in a way that isn't fucking annoying. That's the plan. So I think the plan of action is first, we have to figure out how to run the Wayland client as a thing that hooks into an event loop. So I don't think we've really set up for that right now, but like typically the way that everything in our window manager works is there's like a couple file descriptors and we just kind of like wait for them to say stuff. And when they do, then we like do an action. So for example, the GPU file descriptor will flag that he's ready to be read when it is time to do a vsync, right? Or when it's time to like upload new frame, like give him new frames to render, right? So we just have to replace that event with one that comes from Wayland. Same with input handling, right? Lib input will wake us up when something happens. We have to make sure that the Wayland client will do the same thing. And it should, right? Because we have some socket that we are speaking Wayland protocol on. And we should be able to say, when that stuff happens, wake up. And when a relevant call happens, like it is time to page flip, emit like the right signal so that we do GPU stuff. And when input stuff has happened, like do the input handling stuff. I think that is the play. So we have to first like expose the Wayland client so that we're like doing this stuff in the event loop, hook it up, and then figure out rendering, then figure out input. Easy peasy, right? Easy peasy. So let's get moving and see what happens. Let's get moving and see what happens. So I guess like we're gonna be in main somewhere in our window manager. I guess this is actually gonna be like construct Wayland client. We're gonna be in main somewhere, and we right now say, I would like to initialize a render backend. Where do we do input? Here. So there's going to be something odd here where the input backend and the render backend are the same in Wayland world. But let's figure that out later. So for now, let's pretend we're only doing rendering, no input, and we'll do an implementation that way, and we'll see how that feels. I think what we should do here is check if we have the Wayland display environment variable set, right? If I say env rep Wayland, or I guess like echo Wayland display, this is how applications know how to like draw a window, right? So they see in this environment variable there is a Wayland 0 thing, and they know to look at like run user 1001 Wayland 0, and they know that if they just like open this socket and start talking to them, they can like get Wayland windows up and running, right? So I think that that's probably what we should do here. Is we should first check if, we probably want some sort of like Wayland render backend. Probably. And we want to check this first, right? So if Wayland render backend init, I don't know. We probably like kind of if ladder this thing, right? And here now we just look at the DRM render backend, which is in a different file right now. So let's put this in a different file as well. Wayland render backend, right? Okay, easy. And I guess what makes sense is for us to start by copying the null backend, which just is saying like do nothing. Starting from here seems pretty reasonable. We say this is Wayland render backend is this. Our initialization is going to look pretty different, but we are going to try to make this interface that implements stuff, right? So how do we do this? We need to return a file descriptor that tells us how to wake up, as well as a service function. Easy, okay. So we probably want to do something like, I guess we need like the Wayland client library set up in some way, probably. So we have our Wayland client somewhere as part of our build already. We should just be able to like shove that shit into our window manager as a like dependency. Make WM, so we should be able to be like add import. I don't know what we call it. So in our example, do we have a main? This guy gets imported as window. So can we just pass in window here as a std build module, and this guy then is just like window here. Okay, and then in Wayland render backend, we can be like window is this guy. Boom, right? Easy. And we should just be able to be like, we have this window. Okay, cool. Cool. And I presume that we have to like initialize this somehow, right? So we initialize with the allocator. Wonderful. What are the expectations on this allocator? Like, is he supposed to be a general purpose allocator? Or what? Yeah. He is expecting proper allocator. So we'll figure that out at some point. But for now, we will just do whatever. So we try to make this thing. And I guess we return a context of, you know, we need some state somewhere. Maybe the context is window. Maybe. I'm not sure. This thing needs to be a stable pointer, so it's actually more like this. Window is... I feel like it should be like this. Window... I feel like we're gonna have some internal state, so we'll kind of make it this. Right, so we'll say context is alloc create a render backend like this. We initialize the context with window is equal to this. And cool. Then context is context, easy. File descriptor is like, there must be some file descriptor in here somewhere. But I think that we should expose it in like a nice way. So maybe we'll just write get fd here as like an API on the window that isn't currently there. Feels like something that it should have. Everybody is fighting over Rust and Phil C. I don't know what that means. I assume Phil C is some sort of like C safety feature thing. Probably. What does this guy have? Probably some stream somewhere. All right. So that's his file descriptor. Device path should come from, you know, compositor, but for now, we'll figure that out later. And I assume this guy checks for the WLAN connection stuff already. Yeah, he does. So he tries to open this thing, and so this thing will fail if it doesn't exist. Wonderful. That's perfect. That is perfect. So then we have these guys, and we'll figure this all out later. Okay, yeah, here. I guess we need to do something to like set this thing up as non-blocking, right? Because I think this client is assumed to be in blocking mode. So when we like read from this thing, how the fuck does this work? We like construct an event iterator, if I remember correctly. And this guy, we say get event blocking, get available event. So we actually have support for this already. Oh, perfect. So wait, this already works perfectly. So our service is like, we do a pointer cast, a line cast, a context to self. We say like self window client event iterator. This doesn't feel right. We're missing something. What does our like example app look like? He has a service function on here. Oh, beautiful. Beautiful. Wait, this is actually perfect. We can almost copy this like directly. Almost, right? It's like we call self window service, and then if this returns true, it's like stood log warn window closed, I think is what this means, if I understood that loop correctly. Right, so this is other way maybe. While this, try handle event, return true if this is true, and then this probably returns true if close. Okay, cool. So this is, yeah, if we do this, then we close. And we probably want to do like close is true or something for now. And then if self closed, return or something, right? Something like this. Okay. Cool. So then we can check the rest of the stuff, right? So we can say like if there is a pointer update, let's just log it for now. I guess we're not doing input right now though. We're just doing if window wants frame. This does something. So what does this do? Who calls this normally? We have our like rendering loop. He's got like a renderer who wakes up every once in a while, presumably. On poll. Hold on. He must register with the event loop somewhere, right? Handler. So he wakes up when the underlying backend asks for a file descriptor. He like registers the underlying backend file descriptor. So this will be our Wayland file descriptor. Then he does what? If we are readable, then we render compositor. Then we call service. And then render compositor, does this guy push buffers into the backend or something? He says display buffer. I see. I see. And then he services it in some other way or something? Yeah, then he services the buffer back here. Oh, okay. So if in init case, he just rips that shit. Otherwise, he services the render backend and okay, cool. This makes sense. This makes sense. So on service, we call service. And all we want to do is say like is there really anything to do here? If wants frame, we have to like unlock something. So to flag to someone else. This is the only thing we have to do is yeah, not sure yet. Not sure yet. Usually this guy is working like OpenGL land, which is not really the case right now, which is interesting. It's pretty interesting. So what does he usually do on swap buffers? He's assuming that he has an OpenGL context to work from. That's interesting. So there's kind of like an issue here where our render loop assumes that he's working with like a low-level DRM call. Because he's assuming that his like display buffer function here like has a specific file descriptor thing to display. And our window abstraction assumes that he is in charge of the OpenGL context, which is not like really true in this scenario. But I think that we can support this anyways. We can probably support this workflow because the window thing here, we can just do the Wayland part of this without doing the like lock front buffer part of this, probably. So maybe this is like swap buffers raw or something. Not sure. And he's going to take in all of these like parameters. Add buffer object to buff params. Okay. What is params here? I see. Yeah, there's like something here that I haven't figured out yet, but for now, we will just do this. So then we can kind of say that on display buffer, we call like self window swap buffers raw. And we will like inject something. Something like that. And then I'm not sure what this locked thing is for anymore. I think this tells us probably if we are allowed to render again. Yeah, this is render in progress. So here, we are supposed to write down this pointer probably. Render in progress, I think, is like, it's like something like this. And we like let this go when we service, I think. So it's like if wants frame, render in progress is false after. Yeah. It's like something like this. Yeah. That looks close. That feels pretty close to the right interface. Current resolution also needs to fix me, come from repositor. I guess this is pretty easy to check actually. This is probably like self window. The size here. Like this, size width, size height, easy. Are these the right units? These are used, so let's do an incast here. This should be more like, we should do checked casts here. Stood, math, int, cast to U32, or else return error invalid width. Then here we throw U32 here, or else return error invalid height. Easy peasy. Okay. Missing field close, so false here. And then this thing I guess is optional, right? So if wants frame, like this. Something like that. Okay, this guy needs to return a rendering backend, which seems fine. I don't know why he's mad, actually. Expected optional type. Oh. For errors, we need to be like this. So this is fail to init, you know, Wayland render backend with some error. Then we do another if down here. Okay, there. Looking good so far. No try here, because it's like this. Okay. Okay, so that compiles, which is interesting. So I suspect that this should do something. I don't know if it'll do something sane, because we're not actually ever swapping buffers. But I'm kind of expecting it to open a window. Yeah, so we see here there's like a Wayland window in the taskbar, but it's not rendering anything. So that kind of indicates that this is using the Wayland backend, but never actually issuing a render because the swap buffers call is never actually run. So all we have to do probably is stick this in here and see what happens. So this is like, you know, initial Wayland client hookup, and then here I guess we are kind of in like new territory of actually render buffer. Okay, so swap buffers raw. This guy wants to take an already exported file descriptor and basically do all of the stuff he's doing here just with that instead. Okay, so this guy, this render buffer type is part of the window manager, which means that he's not known by the window API. So I think that we kind of want like raw buffer here to just kind of be his own thing. And I think what we want to do is we want to kind of make it so that this existing swap buffers function is implemented in terms of swap buffers raw. That's kind of how I'm feeling right now. That's what makes the most sense. So I kind of think that we want to do, maybe we have something like this. From EGL or from GL or something. And here we pass it, I guess we just call here. I guess it's from GBM is what we'll call this. So this guy has some sort of GBM context. And he is going to call, I guess it's not the context. He's going to take it from the GBM buffer. That makes more sense. That makes more sense. So he's going to be like, I have some GBM buffer, and I need to turn this into our raw buffer for use later on. Does this guy need... Okay, cool. And so I guess it's probably almost like all of this stuff has to come out, right? Almost certainly every function that we implemented on this was because we needed to expose it. That would be my guess. I mean, all of this stuff seems relevant. So... okay, how do I do this? Delete, record a macro, delete word, find the bracket, delete to the other bracket, put a colon, end, comma, delete, go again. Okay, easy. Why is this not correct? Something is unhappy. I don't know what here. What is though? Okay, weird. Okay. So then I guess it's just like for each of these, it's like this, jump to the colon, put in equals. This should be GBM buff dot, and then go back to the beginning of the line, yank end, paste, put brackets, put comma, go again. Boom, 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 boom. And then this is GBM buff here. Wonderful. Okay, so now all we have to do is we basically say swap buffers raw, given raw buffer from GBM of the front buffer, right? Then all of this stuff kind of moves down a level. Yeah, all of this goes in here. And so now we just have to say, this guy takes in buff as a raw buffer now, which means basically we just take the brackets off like everything because we already converted. Okay. Looking good so far. Looks like we need an allocator here. Looks like. Why? What is this used for? What is this used for? Oh, I see. So again, this is expecting this client was written before we like changed our like our overall memory allocation scheme. So this thing just needs a general purpose allocator everywhere, which is fine. That's just his expectation. But otherwise, I think he's fine. I don't see why this wouldn't work. I guess it's fine. Yep. Ooh, compositor owned buffers. This is a little tricky. So we do usually want to return these guys back. So how does this work? I guess this goes up a level like this, and when we're not, we kind of do this like this. Cool. But we do need the WL buffer ID here somehow, so I guess this returns the buffer ID or something here? I'm not sure yet. I'm kind of just going where the errors take me. Kind of like this, I guess. That feels kind of right. Okay. So now this guy needs to convert this thing into a raw buffer. So, client raw buffer is raw buffer, window raw buffer, and we do our conversion. So kind of just rip this shit, who I assume is almost exactly the same. So we'll do a little QQ, put a dot, yank to the end of the word, find the colon, put a paste, comma, delete, go again. And we'll kind of see. Someone might be a little mad here, but we'll see. We forgot to say this comes from buffer dot here. Bing, bang, boom, 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 boom. Boom. No field name modifiers. Maybe modifier singular. No plain index. Probably just take that out. I guess we probably want to assert that the plain index is 0, because otherwise we don't know how to fucking use it. Then what else is he yelling about? Expected U32 found I32. Stood math cast U32. Alts return error invalid width. Like this, I guess. I don't know, man. Just fucking run this shit around, see where it goes. This guy wants an allocator? I guess we kind of shove this here, unless the window has one. Nope. Note needs to be GPA, and we will fix that at some point. Okay. Okay. I wonder if that works. We were close. Something happened. Nothing good. But something happened. So let's try to figure out why we're freaking out. What is going on here? Oh. Okay. So once we dispatch this, he tries to close it, and then he gets mad because it's a bad file descriptor. Why? Is it because this guy also closes him in here? Maybe that's wrong. Yeah, he does double close it. Okay, we just move this out for the normal swap buffers, for the non-raw version. For now. So this const raw buffer is this. Okay. And then defer close of raw buffer, buffer FD. There we go. Okay, so now we won't be double closing. Okay, so good-ish sign. We are seeing our background kind of like, we are seeing like the expected behavior that our Wayland window manager background is supposed to flicker from like dark to bright red. Now, obviously something else is fucking busted, right? But we don't really know what that is until we kind of see more. I assume that this like striped bullshit is something related to our cursor being rendered incorrectly. I would love to see what happens if we try to run the demo app on this thing. So we're seeing nothing show on here, which is bad. But we're also seeing like texture import failed, which is interesting. I think we saw something about that. Oopsies. I got the wrong state. We're also seeing like a bunch of... Uh-oh. Did my stream go... Did we F there for a second? Looks okay. But it looks like we are getting release events for unknown buffers spam, which is probably a little scary. Got release events. So who's even... WL buffer release in window. Oh, because compositor owned buffers is no longer the guy here. Interesting. This is actually an okay thing to be failing. That's not the end of the world. As long as we release the buffer from the interface list first. And then actually technically here, yeah, it's fine. I think that's fine. I'm not sure. Not sure. Okay, so the question is why is it fucked? Let me think. So we have a couple of problems here. One is that it felt like it was memory leaking. Right? That was one problem. We should double check that. Didn't I just fix that? Okay. So does it look like I don't see any like massive growth on swim here. Maybe we do. We kind of see this number just kind of like consistently growing. You know, which is a little scary. It's weird that I don't see it here. Okay. Growing by like 4 bits at a time. Yeah, which is a little scary. Oh, we aren't passing it a general purpose allocator, which we know is a problem, so we should fix that. We should fix that. Because we're just fucking... Yeah, can we just do this? I think that just happens to work. Okay, so now this number is looking fairly stable, right? Which is... Dude, is that virtual memory of 1.7... Is that like an insanely high number? What are the... Is this fucking VRAM? That's 1 meg? Oh, is this in bytes? Sometimes it's in kilobytes and sometimes it's not, and that fucking throws me. pgrep swim top PID this. Can we just do this? I think it's bytes unless it has a suffix, right? But yeah, hold on. There's a way to change like the memory unit. E. No, that's definitely 1 gig of virtual memory, which is like fine, I guess. And then 107 megs of actually used, probably because something is like over allocating and not using it, which is like fine. That's fine. Okay, so it's stable though, which is good. 1.7 gig is a lot for VM. Yeah, I agree. I agree, but it might be like some like intentional overcommit for scratch space or something that we just haven't fixed. We probably did something stupid as like a hack at some point, and we're just running with it. Okay. So when we run our demo app, so we don't see anything that indicates that the demo app is running here. It looks like just like the width, height, and stride of this thing is all wrong, right? Could also be arenas over allocating. Yeah, could be. I don't think so. I don't think that's how we implemented it, but could be. Also 69 megabytes of shared is a little interesting as well. But yeah, okay, so the question I guess is, why is this not showing anything interesting? Okay, let's see if we can figure this out. So when we render, we are supposed to initialize our window with some resolution, I guess, which we're just picking some random resolution that it's happy with, which is 640 by 40 by default. Then this might be a little interesting. This like device path recovery from compositor log. That's fine. Current resolution does return the one that we get from the window manager, so that should be fine. Oh, we might be picking an invalid color format. How do we do that? GBM system GL. We're hard coding XRGB 8888, so that should be fine. Oh, wait, I've missed this texture import failed. That's probably the next thing to look at, right? We're seeing spam of failed to import texture, import failed. Let's look at why that would be the case. That's probably the most interesting thing to look at next. Failed to import texture. So I'm noticing int max in there too. Yeah, I think that's like a damage. That damage is supposed to just be like re-render everything, re-render the world. So I think that's okay. I'm more interested in this failure to import. Okay, hold on. I want to go back to not using this. Oh, you know what? You know what? I bet you this is creating, yeah, this is creating a EGL. He's rebinding EGL and GBM inside. So he's initializing his own OpenGL context, which is fucking annoying. We don't want this when we're initializing our thing this way, because we are intentionally sidestepping all of this. Yeah. So just temporarily as like a hack, this isn't the way I want to implement this, but for now I'm going to say like with GL. And here I'm going to say like var GBM context is a system GBM context like this, and EGL context as well. Then we say error defer if GBM context this. So kind of like switch these up like this, and then these guys say if with GL we do this. Okay. Then here, these guys are like this, optionals. Really, it's just like this client needs to be refactored so that we have the option to. It needs to be refactored so that the GL context and the window are separate. But for now, this should be fine. Okay. Okay. What's this about? Found. Oh. Rupees. EGL context here. If self GBM context, maybe. This is all fucked, by the way. I'm not happy with this like at all. But these are the hacks we do as we are experimenting. This is interesting. This is interesting. So our width and height usually come from EGL, which they won't come from now. Interesting. We're gonna hack it for now. We're gonna hack it for now because I don't know what else to do. EGL context is self EGL context or else return error no context, and GBM context is the same. Okay, this stuff goes like this. Now do compile? Yes. Okay, does this work better now? So now when we run this thing, is he happier or less happier? Happy or less happy? 1 or 2? He is still failing to import texture, which is interesting. I was hoping that would change something. But it looks like it did not. It did not fix our problem. Okay, do we have our GL debug message callback set up? We do. We do log debug here. Let's change this to std debug print so that it becomes a little bit more obvious if something is wrong. And let's see if he yells at us about something. No, he's not really. The OpenGL callbacks aren't yelling at us, which is interesting. Okay. So we are saying create an image with these buffer parameters. And if the import fails, we say we import fail if EGL no image. So I guess we need to look at what this function returns and figure it out from there. And I think that this is using an extension as well. So we're gonna have to check that we're gonna have to look at that as well. I can't remember. I guess we just look for this. If we look for this, we will find this guy. Okay. No image. This is a not in here. Okay. No image. Returns no image on failure. The contents of the buffer will be unaffected. So, oh, they're right. So EGL flags this stuff differently. We have like EGL error here. And can we see what this is? At least? Like what is he complaining about? Let's take a little peek. 3009, okay? So we're looking for like bad context. So 309 is bad match. So we're looking for bad match in here. So it looks like bad match is thrown if this is a format not supported by the EGL. Interesting. Interesting. So can we look at the format? This is maybe, I mean, this should be strictly RGB888, I think. This should be like, this format string should be XR24, if I remember correctly. But we can look. So this is std mem as bytes, buffer format. Let's see. Yeah, this is just XR24. So the fact that that's not a valid format is confusing, right? That doesn't seem right at all. But it also does not seem to say that about anything else. You know what I mean? So that's kind of weird. Could be like an offset alignment thing. Yeah, it could be. It's what's weird to me. The weird thing to me is that if we go back to using the null render backend, this doesn't fucking happen. Right? I think that's something that we should be kind of focusing on. Right? So if we kind of change this like our like init function here to basically just immediately give up and use null render backend. I believe that this doesn't happen. Oh, it does. Oh, interesting. So that's a good clue. Can we run our like actual client then? Let's try to like back up a little bit, because there's more things that can go wrong with that one. With the, well, not more, but like there's more unknowns with using like a proper OpenGL window. When we use our thing, we kind of know what we're dealing with. Oops, wrong. Right, here, this is succeeding. Right, so that's interesting. That's interesting. And so maybe if we go back to the proper, you know, we use Wayland render backend like God intended. I wonder if we will see something here. Okay, so this is a good sign, right? Here we're seeing some motion that resembles our guy. The stride's wrong or something. But there's something in there, right? So I think the next thing to do is figure out why this is wrong. Resembles in the loosest way possible. Yeah, there are like some pixels in there that we like. So let's say we are on debug wacky buffers, wacky look. How do you say this? Like debug like corruption, I guess. So it feels to me like we are sending the right data with the wrong information, right? And it feels like it is related to when we render everything. It could be that there are like restrictions on the stride. Maybe. Could also be, hold on, can we just run our client for a second? So the good news is that our client on its own is still rendering something semi-correct, right? So our refactoring to rearrange that like raw buffer stuff isn't causing any like major problems there. So it really feels like, this is wrong, by the way. This is wrong. It really feels like it's something to do with how we are passing this stuff around. I mean, it really could be that there's limits on the stride. Is stride even used in here? Yeah, it is used here. Offset stride. Oh, we could take in plain index here, by the way. Interesting. Interesting. I wonder. Yeah, we're not checking we're not checking what modifiers are like supported by Kwin at all. We're not checking that, which means that maybe Kwin's like, I only want things that have certain strides, and we are ignoring that. Maybe. But then we would be passing like invalid modifiers, I would think. Could be like planes as well, although our plane index is hard coded at 0. Or like we are confident that the plane index is 0, so that's fine. I'm curious just to look at the stride here. Yeah, we'll do this. Can we actually just print the whole thing? I'm just a little curious. Oopsies, wrong thing. Stride 2560. Oh, maybe this isn't bytes. I think that might be it might be a unit problem. Might be a unit problem. Let's see. Add here. Stride and bytes. No, that seems right. Seems right to me. Let's look again. I mean, this does look like if the stride was wrong, though, right? Like, it just does look like that. Is it possible that we are multiplying it by the pixel format in here because we knew that that it was wrong? Stride just comes from here. Hold on. 640 times 4, 2560. That is the number I saw. I am curious what happens if we just, you know, on a whim. No, he doesn't like that. Interesting. So it feels correct in that if I do anything else, you know, he's like, yo, what the fuck? Right? He's like closing the connection if I do a different stride. So like, what the fuck? It could be like buffer locking shit. You know, if like somehow we're like clearing the memory of the buffer that's in use because, I mean, this locked is true. Yeah, I wonder if there's something there. So this is called, by the render loop, we swap buffers, lock the front buffer, okay, and then we're supposed to be running to the back buffer, I'm pretty sure. We display that thing, and this value will be set to true internally. Then, if we are not currently rendering, then we're good. Yeah, that's interesting. I think that's all correct, right? It's correct in the other case. Because that's what we do in the like window, like main loop as well, usually, right? So in the non-raw case, We call swap buffers, we lock the front buffer, and then we unlock it later. I guess technically we don't unlock this buffer until it's done. Oh no, we do. No, this is the same here, right? So we only... Yeah, I think it's the same. Huh. Huh. What if we tried a different window size? Just for shits and giggles. Just for shits and giggles. Let's just... You know, just let's see. I mean, this looks a lot like our stride is like 4 times too big. You know, it does just look like that, but I don't understand why that would be. It just feels so wrong. Or maybe our width is wrong. But again, like how we're literally just passing it along in the same way. Really feels like, unless we're doing something like brain dead stupid here, but really we're just like fucking passing along the same thing. I just want to see. Oh, that, of course, that only changes the width. Like, it really, 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 really feels like this is like the stride is wrong. You know, it like really feels like that. Or like the color format is wrong somehow. Is that somehow a possibility? How are we passing like the color form? The format's right here though. It's right here. How strange, man. View offset stride, modifier width, height format. I don't have experience with Linux, but why Wayland exists doesn't have something already called X11. Yeah, it is like the new. It's X11 had like deficiencies slash like assumptions and overhead based off of kind of like an old design, and Wayland was an attempt to modernize that design, which comes with its own baggage for sure, but generally feels pretty okay. Okay, we need to figure out how to fucking debug this. We need to figure out what we need to do to make sure. So let's only ever render once. I want to see what happens there. I feel like that does something for us. I don't know what, but it feels like it does something. Oh, you know what? This feels fucking wrong too. This like force a render, forcing a render before servicing all of our existing connections feels like a problem. And also I'm curious if this, does this service do everything in the loop? It does, right? So I'm kind of curious what happens if we do uncomment or comment out this first render. Okay, that's not it. Okay. My brain. My brain, my brain, my brain. I would also be interested in trying a different color format. Maybe? Because I think Kwin might prefer 10 bits per pixel. I saw that somewhere. Let's just try that on a whim. We got to poke and prod something. We have to take an action, right? So we might as well take an action. X RGB 2 10 10 10. Like what happens? Okay, let's just do this. 2 10 10 10. Let's just try a different color format and just see what happens. Different, but not good still. We're just spitballing. Okay, he doesn't even like that one. What about something like this? 16, 16, 16, 16. Let's just try it. Yeah, okay. He doesn't like that either. What about the floating point ones? Might as well try it. Okay. None of that is helpful, which is not surprising at all. Can we characterize how this is broken again? I want to... Okay, so... we are seeing what? It's like... this is supposed to... the monkey is showing up like somewhat in the middle. We're seeing like the texture... it feels to me like we're also definitely seeing garbage memory, right? Like... ooh, can we log the stride again? 3584. So 800 times 4, 3200. Right? So what you might expect to see here is you might expect to see that there's like padding on the right side of this image of garbage, right? Stuff that like, you know, you need your memory to be in some width multiplier, but you really only care about the stuff that's here, right? So you could see a world where the monkey, like this memory is all just kind of like random shit, and we're like seeing that in here, maybe, right? There's also like some sort of pattern to how it is wrong, right? You're seeing like small segments of stripes along, like around this wide, right? So there's something there where it's like some alignment is not working the way we expect it to. I wonder if horizontal and vertical are swapped. Yeah, it does look something like that. And I guess that is like a type of error that could actually happen and like compile and work correctly. Right? That's not a crazy guess. So where would that go? That would go in rendering, like Wayland render backend. We could like swapping this, I think, works. Because it does feel somewhat along those lines. No, he doesn't like that, I don't think. Connection reset by peer. Invalid buffer stride of height for plane 0. So that's interesting. Can we like just hear me out? Oh, okay. We're gonna have to look at maybe check that the star is multiple one of the dimensions. I mean, it's not. We could maybe try to coerce it to work that way, right? We could try to make sure that our width and height are like sane. We did fiddle with them a little bit at some point. But we could try to do like, you know, 1024 feels kind of safe, right? That's a power of 2. Let's see if that changes anything. Like a big power of 2, right? So now our stride in bytes is 4096, so a direct multiple of this thing. But we're still seeing something fucked, right? I really like it. We can definitely diagnose something from this. I don't know what. Yeah, it really feels like it feels like you're supposed to like half the width of this thing almost. Like we're showing like 2 rows per row. Okay, how can we need to bisect something. I don't know what. Just something. Can we try an external EGL and GBM initialization on the normal Wayland app? Maybe that, or the example program, right? So this example program is using like the built-in ones. Can we ask him to like initialize his own in the same way that we do over here? Yeah, let's try that. So let's just kind of copy paste these guys real quick. Okay. And then I want to initialize these the same way we do. Hold on. There's something here where we're initializing our OpenGL stuff after we initialize the render backend. And it might be that, like, he doesn't want that. No, that shouldn't matter. I don't think that should matter. Okay. Let's try, okay, we go back to our example app. And we kind of just try to do what we're doing over here. So we say, initialize this with our own external OpenGL context. And then after we initialize the window, we do GBM context is GBM context init with window, this is 1024 by 800 or 600, I think. And EGL context is try EGL context init alloc GBM context or something. Okay. Something like this. And then since then we are trying to do swap buffers raw here, which means that we manage our own EGL context like this. And we are doing the same like conversion that we were doing in our other app. So that was in the rendering segment here. 768, my dude. So we need to do that same conversion as like Wayland render backend over here. We do the same conversion here that we were doing. Okay. So this is like front lock front. We need to do this only when this thing finishes somehow. So, but that's okay because we're only doing this in once frame. Okay, cool. So this is swap buffers raw with client raw buffer. We need to store the last buffer. Because we need to unlock it. We need to like return it to the GBM system. So if last buff be we unlock here. And then this is last buff is equal to this. Yep. Okay. There we go. So if we run this guy directly now, he's mad because I actually want to run this on the normal display. Vertex shader compile. Ooh, interesting. Whoa. Wait, why does this compile at all? Oh, it doesn't. It shouldn't, at least. Oh, oopsies. I see, okay. We need to pass in whatever the fuck he's looking for, which was the GL bindings here. So this is like, ew. How can we hack this? Yes. Yes, we can. We are hacking things all over. GL bindings 2. Maybe this is actually just fine. We should be careful. It's fine. It's fine. I think that those bindings are almost exactly the same. If they're not the same, then get fucked us. But I think this should be fine. And then what do we bind these as? It's like GL bindings. Oh my god. GL bindings here gets passed as GL. Okay. I see. So we're actually kind of chill to do this, I think. We'll just do this for a second. Just do that for a second. Okay, close. Close. We're getting close. We're getting close. Okay. This guy's mad because this has to be tried. Uh-huh. Please, God. Okay. Okay! Wait, that's good news. That is good news. So it's broken both ways. Or sorry, it's broken. So this is a result of us doing the external OpenGL management. And we are fairly confident of that. So then the question becomes, why? Let's just try a hard coding. Obviously not. Okay. So, what is the fucking difference? Can you do it with only one render buffer? I don't know. Because I get what you're saying there. It is a little sketchy. Okay, so the normal swap buffers flow, this one we know works. He calls swap buffers, locks the front, and then this wants frame gets set to true. Oh, interesting. This gets set to true whenever we get WL callback. But that's not when this buffer is released. Right? Like, what should be happening here is we're allowed to send more than 2 frames at a time, I guess is what's happening here. And I think that if we move this wants frame down here to when the buffer gets released. No, not quite. But there's something here. I feel like we're releasing the buffer too early. What if we just, in this example, never unlock the buffer? Just like fucking leave that shit, you know, forever. Obviously, it will fall over because we can't lock front. Right, so we can kind of do this, where if he runs out of buffers to render, he gives up. But even with that, we do seem to have like a similar issue. Part of me wonders, let me double check this window in it again. Are we like doing anything stupid like trying to use OpenGL calls directly? I don't see any like use of GL import here. I guess system maybe, but this is only for the EGL context. So there shouldn't be anything going on there either. What am I missing? Because in my mind, the swap buffers and swap buffers raw case are like, should be almost the same, right? Because we're just like moving that same initialization outside. I guess it's technically not the same initialization because we're using a different implementation of this like EGL context function. So it could be something to do with that. It could be, right? So if we look at like our main context here versus the one that we were using before, like how different are these, right? Maybe that's something to look at. This is different. Oh yeah, you know what? I bet you this is it. I bet you because we are forcing linear modifier on the other path, it will pick a better version of this thing. Yeah. I want to try this for a second. So this like modifiers thing says like, this is like, if I remember correctly, force linear, whatever the fuck that means. I guess we want to check it the other way actually. It's like, bring this guy up here. Yeah. Yep. Okay. I see. So it is the modifiers in use are, he's unhappy with them. Which is interesting. Interesting. Because I would think that like we're passing the modifiers over that our buffer is using, he should be happy with them. But clearly that's not the case. Okay, so we can kind of we need to there's a reason that we undid that change. But we'll just kind of ignore that for a second. Okay, so we'll undo all these hacks over here. Fuck this shit. We should understand now that the fix is in our GL initialization on the window manager We want to do with modifiers. And we want to pass in modifier 1. And we think that if we do this, he's going to be happier. That is what we are hoping. Oopsies. I undid too far. I undid too close to the sun. There we go. Okay, so we run our window manager. He is, look at that. That's much better. We see like something that it looks kind of sane. And then we run the client here. Oopsies. The fuck? What is happening? Hold on. God damn it. We broke something. This used to be like this. He's still unhappy. We can't fucking build this shit. Are we in the wrong fucking environment? We might be. We might be. Alright. Vertex shader compile breaking now is very strange. I think maybe it's because we changed something in BuildZig. Maybe? Did we get logged? Yeah, damn. What the fuck is going on? Why can't we fucking compile our vertex shaders anymore? I guess that's new? Like, what the fuck? Yeah. Oh, hold on. Didn't I just undo all that shit? I remember hitting undo on this. What the fuck is going on? I'm lost. I'm lost. Whatever. Delete all this. Delete all this. Get this shit out of my life. All this shit. Away. Away with you. Okay. I don't understand why our vertex shaders used to compile and now they don't. So we need to... This is fine. Oh, because that's... This should be true. My bad. My bad! And then... Yeah, it's fine. Much better. Okay. This is back. And then we run him in... Wayland display equals Wayland 1. Let's fucking go, baby! Let's go! That's fucking sick. That is sick. Okay, so now what we have to do is hook up input. Input time. Sick. Okay. So what's interesting about input here is that before we had like 2 disjoint input and display backends, right? So is it spinning like that on normal Wayland compositor? I think so. Hold on. Hold on. Like, this is a normal Wayland compositor here. That looks about right, right? I mean, the monkey? Yeah, that's right. And then we run that on ours as well. It's the same, I think. Did I miss something? Was he upside down in one? Sometimes he's upside down in one. Oopsies. Wrong. So he starts right side up. Wayland display equals Wayland 1. No, that looks right. Looks right to me. Looks correct to me. Okay. So the interesting thing about input here is that we kind of have the rotation seems to go in ellipses. Oh yeah, because the implementation assumes like a square window or something, and it's not square. That's the only reason. Is because like something's assuming one by one, it's not, and it gets worse the like more stretched it is, which is just like it's fine. That's like that's a bug I understand. So here we have like disjoint input and render backends, but in the context of the Wayland thing, it's like one backend for both. You know what I mean? So we need probably, I would assume that what we should do is maybe construction of the input and render backend have to like kind of live together now. Is kind of how I feel. So let's just kind of like shuffle initialization around so that we can get things in the right order. Ooh, compositor state can't be initialized until we know the resolution. But the input backend needs a compositor state handle. But we can, this is actually okay, I think. Oh no, the input backend is the only thing we need up here, which is fine. Okay, so that's fine. So I think that what we might want to do here is we might want like system in it or something, right? So that we can kind of create a combined input and render backend that both live from Wayland, but that are disjoint otherwise. Because we can't register like the same file handle for wake up from like multiple contexts. He kind of needs to be like owned in one spot. So I guess we have two options here. One is that we refactor a bunch such that we can have one file handle for both. And option two is that we just use an event file descriptor to pass between the two. Which maybe is easier. We still would need, right? So we kind of say like, you know, the Wayland stuff will live in the render thread, and then he'll just kind of like pass things on a queue to the input backend. The other option here is that the input backend just is stubbed out for Wayland, and it just all happens in the render backend. That's like another option, another easy but kind of hacky option. But I think maybe I like that the best for now. Because the input backend is just like, he literally just throws things in compositor state. Like each implementation is like fully free to do whatever they want to the compositor state. Toodles. But the render backend doesn't have that freedom right now. But I mean, we could just do this, right? Init render backend compositor state. You know? Right, something like this. Compositor state is import compositor state here. He kind of stashes this shit here. Like this. And let's just put a note here. Compositor state is not initialized yet. Careful. And we just kind of rip that shit in here. Okay. Then when we init the render backend, we kind of do like compositor state here goes like this. Okay. Then down here, now when we have the stuff we need, it's like compositor state is equal to this. And then we pass in the compositor state here. Which feels kind of right. Then what the fuck? What is he pissed about? Oh, here. Okay. And so then we should be free in like the render backend, which is a funny place to do this, but like whatever. You know, here we have the freedom to be like, if wants like if there's a pointer update, I think we just like set the compositor state point like notify cursor position of like this. I think that's sufficient almost. Yeah, look, he's moving the pointer around now, which is pretty sick. Our client needs to support hiding our cursor on top, but this is like good enough for now. Definitely a hack. Definitely a hack, but a hack I am okay with. Because it's much easier than doing the correct thing. And then I guess we just have to make sure that the input backend is like definitely not doing anything in this case, but I think it's fine. All right, cool. That's a big win. Let's one last demo. Look at this bad boy. Look at this bad boy. Here is our fucking Wayland client running in a window, input working, graphics working. So this gives us like a good place where now when we try to get into stuff where we try to actually implement like window management, it'll just be like way easier to debug and way easier to test. So happy with that. Happy with that. Thanks for watching, guys. If you like what you saw, we stream most days. Week manager, well, I'm a window manager and a window manager. Yeah, hell yeah. Yeah, we stream most days, 12:30 to 4 o'clock Pacific time. It is 3:45 Pacific time now. We just hit daylight savings, so the schedule is a little different if you guys are somewhere that does not do daylight savings at the same time as we do. I don't know how it fucking works. But yeah, most days, 12:30 to 4. It's about 4 now, so anywhere between 3.5 hours ago and now is when you should expect to see us live. If you're watching live, there's a YouTube link in the Twitch description where stuff goes up. Not everything, but most, you know, but probably around like half. You know, it's enough to follow along for sure. If you're watching on YouTube, there's a Twitch link in the YouTube description. Swing by and say hi if you feel like it. If you're online at the right time, please consider supporting. You know, Twitch Prime, YouTube members, and Patreon are all great places where, in return, you get the happy hour VODs, which are just kind of like less feature development or boring feature development, refactoring, unit testing, that type of shit. And you also get, you know, the knowledge of knowing that you're helping the stream continue. You know, if I ever run out of money, I am going to have to get a job and this will stop. So that's the incentive. But yeah, I think that's it. YouTube, peace out. Twitch, let's find someone to raid.